Hi, this is Ayushi. I have completed my bachelor's and master's degree from NIT Rourkela. This is the numerical of 10th standard from the book R.D. Sharma, and the chapter name is Circle. So, let's move forward with the problem. In the question, it has given that if A, B, C are the side of right angle triangle, where C is the hypotenuse. So, at first, let me draw a triangle. Which is right angle. It is already mentioned. So now it has been clearly mentioned that C is the hypotenuse. So this length is C. And this length is B, or else you can also take this side B. I will name it later. So let this name be, this point be X, this be Y, and this be Z. Okay. So now it is written that prove that radius of the circle which touches the side of the triangle is given by. At first, let us go to this part. Radius of the circle which touches the sides of the triangle. What does it mean? It means that circle is there inside the triangle. Then only the radius of the circle will touch all the sides of the triangle. Here I want to give one more clarification, that some of the students might be thinking that if the circle touches the triangle, then why can't it be this this kind of triangle where circle is outside of the triangle? Okay, so but in this case, as we can see, radius cuts the triangle. Okay, so it is not possible, but in question it has clearly mentioned that radius only touches the circle. So it clearly justifies that circle is inside the triangle. So let me draw one circle inside it. So this is the required circle which touches all the sides. So now it has been asked that we need to prove that the radius of the circle is given by this formula, this formula, or radius equal S minus C, where S is the perimeter of the triangle. We need to do some of the extensions. So this is the way of writing in the board exam. So look at this very carefully, how I am proving it. To prove radius equals A plus B minus C by 2. So now what you need to do? You need to define the extensions, or else you can also write the construction. Let me write it properly. What are the construction that we are going to do? See, this is the center. Okay, so we will draw one perpendicular to this side, to the xz, and one perpendicular to xy. Okay, and this is the radius. This is also the radius. We will draw one more line. It will be radius. Okay. As you can see, the triangle sides are the tangent. It acts as a tangent for the circle. Okay, so let us move forward. What the construction we did? Let me name this point as E, and this point as F, and this point as G. It will be more easier for us. So OG, OF and OE, OF and OG, they are equal as their radius. So now you will be writing like this: perpendicular line was drawn to tangents. These are in the steps when you solve the board exam, so that is the reason why I am focusing. Okay, these are very important steps, construction. So observe this very carefully. Now what we are going to do, at first we will write YZ. So what is, if we will break down it in the equation, what will it come? YZ equal YC, this one, YC plus CZ, YG plus GZ. Okay, YZ will be YG plus GZ. Okay, so now what is our YZ? Our YZ is C. So C equals YG plus GZ. Let me name this equation as 1. So now here we should recall one theorem, that from an external point, if two segments of line are drawn towards the circle, then these both lines are equal. Okay, so similarly YE, YG are equal, and XF, XE are equal, and ZF and ZG are equal. So I am writing this. You need to write the theorem also, so I am writing the theorem also. Let me name this OA, OB, tangents drawn from an external point tangents drawn from external point to circle are equal. So now we will use this theorem, as I have already said. YE equals YG, and let us go back to the diagram. XE equal XF, XE equals XF, ZB equals ZC. ZG equals ZF. Okay, so there is an observation, as we can see here. Construction was done such that OF is perpendicular to XZ, so it is also a right angle, and OE is perpendicular to XY, so this is also right angle. So definitely it becomes a square, and we observe that XE is parallel to OF, and also it is equal, XC equals OF. So let me write here, XC equals OF and EO equal XF. EO equals XF, so which is nothing but the radius. So now what we get from it, XC equals XF equals R. Okay, so this result is very important. I can also write it here, equal R. Okay, see what we need to prove. We need to prove that radius equal a plus b minus c by 2, and for that purpose what we did at first, we expanded yz, and then we are taking the help of the theorem, tangent theorem, so that we will be able to get our answer. That is only we are doing. And then you all might be wondering that what is the use of XC and XF. So let me remind you, as notice this part, when we need to expand xy and xz also. So if I expand xy, it will be xc plus ey. So xy will be, just let me write it properly, xc plus ey. So now we know that what is our xy, it is nothing but a, so in lengths. Okay, and what is this? It is our radius, as we have already proved here. It will be our radius. So this is our radius and it will be as it is. It becomes a minus r equals ey. And from this result, for easy purpose, I have named the equation as 2, 3, 4. So Ey can be written as Yg. So again similarly, if we will expand x z, it will come xz will be xf plus fz. So what is our xz? Our xz is b. It is b, and we have already defined what is our xf. B minus r equals fz. Fz is also equal to Cz, due to that property which I have already told, that from an external point, that the line from an external point to a circle are always equal. So Bz equals Cz. So hence, Fz is equal to Gz. So now substituting this result and this result, what we will get for, just wait, what we will get for yz, as we have already defined that yz is yc plus cz. Okay, let me write this properly. What was our yz? It was c, and it will be, just wait, it will be yg plus gz. Okay, so now what we found about yg is nothing but a minus r. Okay, so I will be writing a minus r plus, what is our gz? It is b minus r. So hence, if we will solve it, c equals a plus b minus 2r, which is 2r equals a plus b minus c, and here r equal a plus b minus c by 2.